Hello everyone. So today let's solve the problem matching in the independent set. Yeah. So this was asked in the code forces around 576 for the division 1. Yeah. So you can just go through the question. It's easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem. Yeah. So now let's do one thing. Let's see what the question states here first. Yeah. We are given a graph with 3 into n vertices. Yeah. We are given a graph with 3 into n vertices and m edges and m edges. Yep. So first, for each test case, we have to find either a matching of n edges. For each test case, we have to find either a matching of n edges or an independent set of n vertices. Either matching of this one, n edges, or this one, or independent set of n, this one, what do we call vertices or edges? Independent set of this one, n vertices or edges, right? I'll just write V here. That's enough. Yeah, independent set of vertices. What we need to print actually, we need to print the appropriate type and the indices. We need to type appropriate the we need to print the appropriate type and also the indices. Yeah, so this is what we need to do here. If both exist actually, yeah, if both exist, then we have to print anyone. Then we have to print anyone. Just remember this. Let me read the question loud. Just listen to this carefully again. So we are given a graph with 3 into n vertices. This is fine, and m edges as well. Yep. For each test case, we have to find either a matching of n edges or an independent set of n vertices. We know this. Yep. Now we have to, all we have to do is we have to print the appropriate type and the indices. Yep. Now, what if both exist actually, type and the indices? We have to print anyone. Yep. So this is the question mainly. Uh, so let me delete this one. Let me come to the input output part here. Right. So here, one thing. So we have been given n here. We have been given n. So and we have been given these many adjustments. Wow. So the output that we need to get here is matching to IND set. This one independent set 1, independent set 2, 4, and matching 115. Right. So this is about the input output. Now, as we are completely familiar with the question and the input output part, let's do one thing. Let's quickly discuss the approach followed by the complexities, and then let's write the code. As usual, let's discuss the approach first. So before hopping into the approach part, let me tell you one thing. So we will be making use of the greedy approach to solve this problem. Yeah. So this is the graph problem, right? Matching actually, matching problem. Usually we call this one as graph matching problem. Yep. So now we will be going with a greedy or the constructive approach to solve this particular problem. So let's go step by step here. So the first step here would be processing the edges in the input order. So we have to process the edges in input order, meaning let's keep an array. So array, you can just name anything. So I'll just go with a visited of V, vertex V actually, marking whether vertex V is already used by the chosen matching or not, right? So we will process the edges in the input order. So I can just call this one process edges in the input order, right? So the first step, process edges in input order, in the input order. So this is fine. Let's move on with the second step here. So after this part, so when we see the edge u comma v, suppose when we see the edge u comma v and both visited of u and visited of v, and both so we have considered the variable visited, all right? So visited of u and visited of v, both visited of u and both visited of v, both are 0. If both are 0, meaning unused, right? So then we have to take this particular edge into the matching, and we have to mark both endpoints used. But then we have to mark both endpoints as used actually. We have to mark the both endpoints, this one, visited of u and visited of v. This one, if it is 0, then we have to mark this both endpoints as 0, used, sorry, right? So now let's move on with the third point, man. So I hope these 2 points are clear, man. So this is what I wanted to this one, what do we call, explain actually. Now let's get into the third part here. Listen to this carefully. after scanning all the edges, obviously we have to scan all the edges. After the completion of scanning all the edges, we either have enough matched edges that is greater than or equal to n, then we have to print the n chosen edges as matching, n chosen edges as matching, right? Then we have to choose this one, n chosen edges as matching. So this is fine. Or you don't, or we don't actually. Then there are at least n unused vertices. Then there are at least n unused vertices, right? So because total 3n vertices are present, each matching edge uses 2 vertices. So if we cannot get n matching edges, we can always pick n unused vertices, right? Accordingly with the question, accordingly with the criteria, or accordingly with the question actually. Then we have to print any n unused vertices as independent set. Then we can print any n unused vertices as this one, independent set actually. So this is the idea that we will be going with. This is the idea that we'll be going with. This is somewhat simple. Yeah, this is somewhat simple. Only we have to know is how to imply the this one, how to implement the greedy or the constructive approach. That's it. Yeah. So this is fine. Now let's try to implement the same thing on the example one, man. Yeah. So not entirely. So let's consider only the part, or let me consider here. Suppose uh, n equals 1 here. Let me consider the example n equals 1, and here 3n is nothing but the 3, because we have n equals 1, 3 into 1 here would be 3 itself. So 3n is equivalent to 3 here, right? N equals 1, 3n is equivalent to 3. So let's consider the edges, these two edges actually, 1 2 and 2 3, 1 2 as well as the 2 3. Let's consider any of the edges here. 2 3 will be there quite obviously. Let's consider 1 2 and 2 3. So let me go with the edges here. Hmm, this one, what do we call, 1 2 as well as the 2 3. So 1 2 and 2 3, right? So now we will start visited initially. Visited, if you know, it will be 0 itself, right? So we'll go with 0 0 0. Initially we haven't visited anything, so we'll set this one to 0 0 0. Edge 1, so let's consider here edge 1, edge 1. Yeah, edge 1 is nothing but 1 comma 2. We are considering 1 comma 2, right? So here both are unused, both are unused. Initially both are unused, both the nodes are unused, 1 and 2. So accept, so let's accept the this one, what do we call, edge 1, so that we can set the visited of 1 and visited of 2 equals 1. Now both are unused, so we will accept this one, accept the edge 1. So then we will set the visited of 1 and visited of 2, uh, this one, visited of 1 and visited of 2, node 1 and node 2 actually, right? Visited of 1 and visited of 2 to 1 actually, to 1. Yeah. So next step is we have, let's consider the edge 2 here. Edge 2 consists of the node 2 and node 3, right? Node 2 and the node 3, quite obviously. Now 2 is already used. If either of the nodes is used, then we have to skip, right? So we have discussed this one. If 2 is already used, right? So I'll just write here 2 is already used here. If either of them, either of the node is used, then we have to skip. So let's skip this one. Let's skip this one. Yeah, this is fine, I believe. Next, let's move on with the fourth point, main point. So we have count equals 1, this one, visited of 1 equals visited of 2 equals visited of 1. So we have count that is equivalent to 1. We have count that is equivalent to 1, which equals n, which is equivalent to the n actually, which is, so this one equivalent to n. So equivalent, we'll check with the double equals, which is equivalent to n. And we have here this one, 3n equals 3. So basically n equals 1, right? We are considering n here. N equals 1 actually. Yeah. This is equivalent to the n. Count equals 1, which is equivalent to the n. Yeah. So output, we will output matching and the edge index 1 here. Edge index 1, this one, edge index 1, and edge index 1 along with the matching we will be going. Along with the matching we will be going here in this case. Matching along with the edge index 1, right? If fewer than n edges were accepted, we'll pick n vertices with visited of v equals 0, and we'll this one print independent set or IND set. In this case, they have asked us to print IND set for this particular input, whatever we have considered. Actually, it's just 1, 2, and 2 and 3, so we have to go with a matching as well as the 1. So this is one of the simplest examples that I wanted to show you guys. Yeah, so you can just consider the same thing for the input that they have given. So you have to repeat the process again, same thing, right? Again, I showed you for the matching, and if fewer than n edges were accepted, if fewer than n edges, less than, right? If fewer than n edges were accepted, then we have to pick the n vertices with visited of b equals 0, and then instead of matching, we have to print the IND set. Index remains same. So instead, we have to print IND set, nothing but the independent set. So that's the only difference, man. Yeah. So I hope the approach part is completely clear. I have shown you by taking the example. Same thing you have to do it for this one, right? So we'll get the output matching to independent set 1, independent set 2 for matching 115. Yep. So I hope this part is clear. Now, as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part, right? So what will be the time complexity according to with the approach that we discussed actually? The time complexity would lead to big of m plus n. The time complexity would lead to big of m plus n for the test case. Why? Because we are scanning the m edges once and then up to 3n vertices, right? So that one I have showed in the just showed you in the this one approach actually. We are scanning m edges once and then up to 3n vertices just to collect the independent set. Just to collect an independent set. Overall would lead to big of some m plus some n, which can be represented as big of m plus n itself. Yeah. So the time complexity would lead to big of m plus n. So what will be the space complexity here? Space complexity would lead to big of 3n plus m. Big of 3n plus m in the worst case, right? So big of 3n plus 1 in the worst case for the arrays, visited sized almost equivalent to the 3n, answer array, answer variable, anything. I'll just go with the ANS here, that can be sized up to the m, but in the implementation, fixed arrays are used. We will be making use of the fixed arrays basically, right? So overall space complexity would lead to big of max vertices plus max edges. In simple terms, we can just go with a max of 3n plus m, right? So let's go with this itself. The time complexity and the space complexity for the code that we'll be writing in the future would be big of m plus n and big of 3n plus m respectively. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the. So the approach that we'll be going with, as we know, according to with the approach that we discussed, we'll be going with the greedy or the constructive approach. Yeah. So yeah, let's start writing the code. So we'll be making use of the fast input and output. Let's import here input output package, right? Yeah, we'll be making use of the different utilities as well. I'll just go with the java dot util dot star. This is fine. Next, what shall we do? Let's go with a class here main. Yeah, as usual. So I can just go with any class name that's relevant to the question basically. First, let's go with a visited. So visited of v initially 0, right? Means vertex v currently unused, and 1 means used by the chosen matching edge actually. We are solving the problems on the graph matching itself. Yeah, so this is fine. So first, let's go with the static here. Int. So this one will be visited equals new int of, let me go with 3 followed by 4 zeros here by according to the constraint. Yeah. So this is fine. Yep. And also let's go with a answer variable, anything. I'll just go with the answer itself here. Static int. So this is fine. Answer equals new int of, so let me go with 5 followed by 4 zeros. This one 5. Yeah. So this is fine. This is the initialization part. Next, let's do one thing. Let me leave space over here so that this looks good. Next, let's go with the main method here. Yeah. So let me delete this also. Let me include here throws input output exception. Exception. Yeah. So this is fine. So within the main method, let's do one thing. Let's go with a fast input reader, fast output writer, as well as the this one t. T is nothing but the number. We have to read number of test cases, right? T. So I'll just go with t here. Instead of the n, I'll just go with the t. I'll just give me a second here. So here, let me copy paste this one. So this is purely related to the input output one. So I just didn't want to type this one. This is purely related to the input output. This one, sorry, input output. So I just copy pasted this one. Fast input buffered reader, fast output print writer. T is nothing but we are just reading the number of test cases here, right? So this is fine. Next, we are just reading n and m for the particular test case, right? So for this particular this one current test case actually string tokenizer, this is fine. N and m I have already explained. So now let's move on with the main thing. So initially, let's initialize count variable cnt to the 0. So this one, we have to go with the number of edges we have added to our matching so far, right? So this is easy, man. Now let's reset the visited of 1 to 3 and to 0, unused ones, right? For this particular test case initially. So I'll just go with here arrays dot fill of visited. So this is fine, comma 1, comma 3 and let me write here 3 and 3 into n plus 1 for the safer side. And also let me consider 0. Yep, this is fine. Simple. Now let's process the each edge in the input order, meaning edges are one indexed by input order, right? So let's go with the for loop here. So this one will be for and I equals 1, I less than or equal to m. So this will be I plus plus. So within the for loop, let me go with the st string tokenizer. Let's create instance of it. So this one string tokenizer br buffered reader dot read line. Yeah. So we have made use of the buffered reader itself. So read line. So this is fine. Now, again, let me go with the this one endpoint x and endpoint y. We have to pass this one, right? Both are integers. Actually, let me copy this one. These two actually. Let me paste it over here, and let me do one thing. Instead of n, let me change the variable name to x, and also instead of n, I'll just go with the variable name y. So this remains same. Everything remains same. So next thing is if both endpoints are used, x and y, if both the endpoints are used, then we can take this edge, particular edge, whatever we are considering, into our matching. So I'll just go with here. If visited of x, if it is equivalent to the 0, and if visited of y, if it is equivalent to the 0. Yeah. So I'll just set this one visited of x equals visited of y. So this is fine. I'll just assign this one to the 1. We are just marking both vertices used here, right? So let me go with the next thing is let's store this particular edge index into the answer variable ans that we have made use of, and let's increment the count variable, nothing but cnt we have used, right? So I'll just write it in this way. Answer of count here. Let me assign this one to the I. So this is fine. Let me come out of this one entirely. Now what shall we do? So here, if we call this one enough matching edges that is greater than or equal to n, we should print matching as well, right? So note one thing here, that original implementation, whatever we are going with, this checks count less than or equal to n, right? Here, which is inverted. Here in our case, it is inverted, right? But uh, we do not change the let's not change the code logic here, right? Let's not the change code logic here. So let's go with the same thing, right? So this is fine. This should also work actually. Let's see whether this works or not. So if uh, let me go with here count. Actually, if it is less than or equal to n, if it is less than or equal to n, so within the if condition, let's print. So basically what we are doing, the branch we are considering prints an independent set. Yeah, int set, right? The interest in the basically the intent of the correct solution, right? So it would normally be to check the count less than n itself, right? To print the independent set. So basically the intent in the correct solution would normally be to check the count less than n itself. So we have went with the if condition count less than or equal to n just to print the independent set, but we will keep the original one itself here, right? So I'll just go with here out dot println. So let me go with ind set here. This is fine. Uh, let's set the j to 0. It's fine. Let's iterate the vertices from 1 to 3n and print those unused visited of I equals 0, right? Until what? Until what? Until we print n vertices. Until we print n vertices, right? So let's do that quickly actually. I'll just go with here for and I equals 1, I less than or equal to 3 into n plus 1, I less than or equal to 3 into n, and j less than n. Let me go with, let me increment I here, I plus plus. So within this for loop, if visited of I, so if it is equivalent to 0, then let me go with out dot println here. So this is fine. I plus, so this is fine, man. Yeah. So let me increment here, j, j plus plus. Yep. Now let's do one thing. Let me, yeah. Let's move on with the further things. So I'll just leave here. Let me consider else here. So fine. Else, the other branch actually prints. So we are printing. We have successfully printed independent set, int set. So the other branch, what it prints, else we have to go with the matching, and the first n chosen edges indices. This one we know. We have discussed this one in the approach, right? So I'll just go with the out dot println here. Let me go with the matching. So this is fine, I believe. Yep. Now let's go with the for loop. So this one will be int I equals 1, I less than or equal to n. So let me go with I plus plus. So this one will be out dot print of answer of I plus space. Yeah. Let me leave the space here. We need the space. Yep. So now let's do one thing. Let's go with a new line after each test case output. So I'll just go with out dot print ln. This is fine. Finally, we have to flush the output. So finally, we have to flush the output. So this one will be out dot flush. Yep. So we have to flush the output. Right. So this is fine, man. Fine. Somewhere something I have done something wrong. Braces again. Brackets. Oh, I mess up brackets, man, many times. So here visited of x. So this is fine. Fine. We are going with bracket. So this one, while I this one I pasted, I think. So I'll just give here. I pasted that while loop. I think I didn't add one more bracket at all, I believe. So that is the reason. So this is fine. So now, before checking the code with the different inputs, let me copy paste the signature starter template here. So let me paste it over here. Let me come to the question. Let me copy this one, the output that we need to get here is this one. Let's check the same. So we are getting the independent set 2, independent set uh, 2 again. So this is fine. So this is also accepted, I believe. Independent set 3, 4, and matching 1 and 10. Matching 1 and 10 respectively. So this is also, we have multiple outputs for this one. Yeah. If there are several solutions, we can print any in particular, right? If there are this one, both a matching of size n and an independent set of size n, then we should print exactly one of such matchings or exactly one of such independent sets. If there are several solutions, print any. Yeah. So this is having the multiple solutions. Accordingly, with what approach that I went with, I'm getting this output. Yeah. So I believe this is correct. I believe this is correct. Let's see. Let me copy this one entirely. So I hope this is correct, man, or else we have to change the entire this thing. Let's see. Let me paste this one and let me hit the submit button. Let's wait for some time. I hope this works for all the test cases, man. Let's see. Wrong test on this one. Uh, just give me a second here. So let me do one thing. Here, I think we have to go with a capital I actually, INT set. So that is the reason it is showing the wrong answer, I believe. So that is the only thing. So all other things we have written, we are getting the correct output accordingly with what the code we have written. The output, this is correct. IND set 2, IND set 2, actually IND set 3, 4, and matching. Oh, if I run this one, capital I we have given. So this one has to work. Let's see. Let me go with here, paste this one again, and let me hit the submit button. I hope this works for all the test cases. The only thing I have changed here is this one, I to the capital I, from small I to capital I here. Let's see whether this works or not, or else we have to get the wrong answer again. Let's check. So, but one thing, accordingly with whatever the code that we have written, yeah, see here running on 33. So whatever the code we are writing, so whatever the code we have written, the output we are getting correctly actually. And set 2, and set 2, this one, 3, 4, and 1, 10. Yeah. So basically, this was the problem. I had to use capital I. They are strict about this one, capitalization actually, of that particular letter. This is fine. Yeah, the verdict that we are getting here is accepted. We are getting the verdict accepted. Means whatever the code that we have written works absolutely correct for all the test cases. Yeah. So we have went with a pure greedy or the constructive approach, man, here, right? Constructive approach here. Solve this particular problem. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.